So hello everyone, welcome back. Today we will be doing on the chapter of acid, bases and salt. Acid is commonly found in everyday life such as vinegar, and what determines it to be an acid is that the key is that it must possess H plus ions. So it says one thing, it says that it must dissolve in water in order for you to get the ion. So some of the common acid that we know, such as hydrochloric acid, sulfuric acid, and nitric acid, they will not be an acid unless they are dissolved in water, which is in aqueous state, which is a unique property for such covalent since it can dissolve in water. Next, we will look at the strength of acid. A strong acid says that it must completely ionized in water to give a lot of H plus ions. And in contrast, a weak acid will only partially ionized in water to give a few H plus ion. However, among strong acids, we also can compare such as HCl and H2SO4. Which one you think is a strong acid? The answer is H2SO4. The reason is because one HCl will expect to give only one H plus, while one H2SO4 you expect to have two H plus ions, hence making H2SO4 more H plus ion, which as a result making it a strong acid. Some of its physical properties is sour taste, conducts electricity because there's mobile ions, and it turns blue litmus paper red. And the next part, which is also very important, is the reaction that you will undergo. You must know these three reactions by heart at your fingertips. Acid will react with metal to give salt and hydrogen gas, which resulted in explosive. That's why you see when you put sodium into HCl, it's very explosive. And the next part is any metal below copper in the reactivity series will not react with HCl because they are very unreactive. So copper does not react with HCl, or does not react with acid. Silver does not react with acid because they are very unreactive. The next part we will look at is acid react with base to give salt plus water and carbon dioxide. And last part, which is acid reacts with acid reacts with carbonate to give salt plus water and carbon dioxide. And the last part, acid reacts with base to give salt plus water. So these two get water, these get H2. Now we will move on into base. All base must be a hydroxide or oxide, and it must possess OH minus ion. And there's two types of base, a soluble base and an insoluble base. Soluble base, as the name suggests, it dissolves in water. That's why you'll get the OH minus ion. And most of the soluble base are in group 1 and group 2. So it's sodium hydroxide, calcium hydroxide, all the group 1 and group 2 hydroxides and oxides. And the insoluble base are the rest. So if it's insoluble, it's insoluble base. For soluble, it must be a soluble base. And look at some of the properties. They are bitter in taste, so give people a soapy feeling, turns red litmus paper blue. And the reaction that you undergo besides reacting with acid is that you will react with ammonium salt to give you salt plus water and ammonium gas. So please bear that in mind. Now we will move on into talking about the next part of ABS, which is the oxides. There's total of 4 oxides that you need to know. And the first two is very common sense, acidic oxide. As the name suggests, acidic oxide has to do with acid. So first thing you must know is that all non-metal oxides are known as acidic oxide. So carbon dioxide is a non-metal oxide because carbon is a non-metal, and oxide, so it's make it a non-metal oxide. It is a non-metal oxide, hence it's an acidic oxide. And if you react it with water, you will get acid. And if you bubble it into a base, a soluble base, because there must be a presence of water, you will expect to get salt and water. So you can react with a base using an acidic oxide. A basic oxide, in contrast, is a metal oxide, such as sodium oxide. It reacts with water to give you base. Bubble it into acid and you will get salt and water. Next, we'll look at the last part of it, which is amphoteric oxide. There's only a total of 3 amphoteric oxide that you need to know. They are zinc oxide, aluminum oxide, and lead oxide. The special property about amphoteric oxide is that it's able to react with both acid and base, making it very unique. When you react with an acid, the amphoteric oxide will act as a base. If you react with a base, it will act as an acid. And the last type of oxide is neutral oxide. A very simple example, water, carbon monoxide. Now we will move on to the last part of this chapter, which is salt. In order for you to do salt and to understand how salt works, you must first memorize or familiarize yourself with the solubility table. You must be able to tell me whether this salt is soluble or insoluble. Then we can go into this. Assuming that you now know the solubility of the salt, we'll go into how to analyze it and how we can actually prepare it. So follow these steps. Input in the salt. So first of all, let's say we input calcium sulfate. You know that calcium sulfate is an insoluble salt. So you analyze, is it soluble, insoluble? Ask yourself this question. If it's insoluble, what must use? You must use precipitation. The only method you can use is precipitation. For precipitation, you require 2 soluble salt. So the common two I would recommend my students is sodium something and nitrate something. These two are the most common because all their salts are soluble, guaranteed soluble. Hence, you can use these two to help you prepare your insoluble salt. And once you prepare it, you pour it into a beaker until no precipitate form. You're going to take the beaker, you're going to filter it, get the residue, and what happens is you're going to let the residue dry, press it with filter paper, and you will get a crystal. As simple as that. Next, we will look at soluble salts. If you know that it's a soluble salt, for example, the next question you're going to ask yourself, is it a spa salt? That means, is it a sodium chloride? Is it a potassium salt? Or is it ammonium salt? If it is, then the only method you can use right now is titration. And titration must use when you react an acid with alkaline to prepare the salt. So let's say, for example, you want to prepare sodium chloride. You must use an acid. So what acid? HCl, because chloride. Then what's the alkaline? Sodium hydroxide, because of sodium. So how does it work? You're going to prepare out 25 cm cube of alkaline into a beaker, and you're going to pour the acid into a burette. And once that is done, you're going to put a beaker under the burette, add a few drops of methyl orange so that the alkaline will have a color. Then you start to open the tap and let the acid drop inside. And until a point where the color changes, close the tap, measure the amount of acid you use, and record it down. Then throw away everything that you have already used in your experiment, reset the entire experiment, but now use it without a methyl orange because you do not want contaminants. And once that is done, take the solution, filter it out, heat it until it saturates, and let it dry, and you will form crystal. And wash with a bit of distilled water, press dry, and you are done. And how about, let's look at if it's a soluble salt and it's not a spa salt. So for example, copper sulfate, zinc sulfate. There's multiple methods. There's a total of 3 methods. You can use acid plus metal, acid plus insoluble base, or acid plus insoluble carbonate. However, in this case, you cannot afford to use acid plus metal because the salt that you want to prepare is copper sulfate. That means that you have to react acid with copper. And copper is unreactive to acid. So hence you have to use another approach. Personally, I suggest use acid plus insoluble carbonate. It works for all soluble salt that is not a spa salt because all the carbonates are insoluble except spa carbonate. So it's very easy and straightforward. So basically you put the piece inside, let the reaction settles, then you're going to filter it, get the solution out, then heat it until it saturates and let it cool and press dry, and you're done. And for the last part of this chapter on salt, which is QA, the only way you can actually master QA is to memorize it, memorize the table, and also practice. Do a lot of practice. Once you do that, you will be 100% familiar with QA and it will not be a problem. So with that, I come to the end of today's lesson. Thank you.